Hello all. In the series of covering SAT topics, this is our video number 20, in which we will learn about properties and equations of circle. So, assuming that you must be knowing about radius, diameter, tangents, segment, sector, arc, these things you must be knowing about. So, we will start with arc length. So, suppose we are having a circle. So, this is a circle. Then, any part of this circle, like this part, is called as arc. And now if we need to find the length of this arc, then how we can find? So first we should know about how much angle it is making at the center. That means central angle is very important in this. So this is, suppose, angle theta. Then length of arc is given by, length of arc is equal to, first of all, before length of arc, circumference. We know that circumference of circle is 2 pi r, where r is the radius. Suppose this is the radius r. Then if you will see how we get this 2 pi r. So when this r radius rotates about the center by 2 pi, then that means one revolution is completed. Then this radius swipes an area of 2 pi r. Similarly, if we are finding the area of, length of this much only, this arc only, then in 2 pi it covers 2 pi r. So in this much only it will be 2 pi r theta over 360, and this will be when theta is in degree. In the circumference formula, as you can see, 2 pi r, where 2 pi is radian. So if it is in radian, then it will be simply r times of theta, if theta is in radian. Now suppose we need to find the area of this. Then we know that area of circle is pi r square. So similarly, here area of any sector, this part is called as the sector. So area of sector is equal to pi r square theta over 360 degree. So this will be the area of sector, or this can be written as like in the length. It is also, if it is in degree, theta is in degree, then we use this formula. If theta is in radian, then we will simply say r square theta over 2. Theta is in degree, radian. This is about circumference and area of circle. Now we will start its properties and theorems. So first theorem 1, which we are going to discuss, is about central angle and inscribed angle. Relation between central angle and inscribed angle. So suppose, let's take a circle. Suppose this is the circle we are having, in which, suppose this is central angle, we have one central angle and one inscribed angle is also there by the same arc. So how we can draw that? We will be drawing by the same arc. So suppose this is our inscribed angle. Now suppose that central angle is, suppose inscribed angle is theta and central angle will be then 2 theta. So that is the relation between central angle and inscribed angle. So we can say central angle is always double than the inscribed angle by the same arc. Like here you can see, suppose this is arc AB, then AB is only drawing these two angles. One angle subtended the center is just the central angle subtended the circumference. From inside it's inscribed angle. If it is from outside the circle, then that is circumscribed angle. Now this is the relation between central angle and inscribed angle. Now we have to do is number 2, that is relation between two inscribed angles by the same arc. So I am writing directly the statement. So all the inscribed angles are of same measures if they are inscribed by the same arc. For example, we can take, suppose this is the arc we are taking. So from this arc we can have many inscribed angles. So these two inscribed angles, we can have even more inscribed angles. Suppose this. So suppose this is theta 1, this is theta 2, and this is theta 3. Then all will be equal. So we can say theta 1 is equal to theta 2 is equal to theta 3 because they are inscribed by the same arc. Now next we have to learn about number 3, that is about tangent theorem related to tangents. So first is a pair of tangents from an external point to the circle, from an external point to the circle are congruent. That means what we can say from here is, suppose this is the circle we are having and two tangents on this we are having like this. Then suppose this is P, this is A, this is B. Then this PA and PB will be equal. PA will be equal to PB. Then number 4 what we have to discuss is, suppose this is the circle. In this circle, suppose one of the tangent we are having, suppose this is the tangent, and suppose this is the center from where we are drawing the radius. Then that will always be perpendicular to the tangent at the point of contact of tangent. So a line passing through center, not only radius, any line, it can be even bigger line segment, it can be even diameter. So a line passing through center is always perpendicular to the tangent at its point of contact. Next, number 5, this is about chord. So suppose this is a circle. In this circle, suppose this is a chord and this is the center, and from the center there is a perpendicular line. Then that perpendicular line will always bisect the chord. So we can say here that a perpendicular line from center to chord always bisects the chord, and vice versa. That means if a line is bisecting the chord passing through the center, then that means that line will be perpendicular to the chord from the center. Next, number 6 is also about chord only. Suppose we are having this circle. In this circle, we are having two chords. Suppose we are having this chord and we have another chord, which is suppose this one. Then suppose this is the center. So from this center, this is a perpendicular line to the chord and this is another perpendicular line to the chord. So what we can do from here, suppose this is AB, suppose this is PQ and this is center O. Then if two chords are at same distance, same perpendicular distance from the chord, then both the chords will be equal in length. That means from here we can say, if these two are equal, suppose this is M, this is N, then if we are saying that if ON is equal to OM, then we can say that AB will also be equal to PQ. That is the theorem related to chord. Now moving ahead, then we have to learn about tangent secant theorem. So number 7, I am drawing 3 circles now. This is the first circle, this is the second circle, and this is the third circle. Now in these 3 circles, what we have to know about is, suppose 2 lines are there. These 2 lines we are having, where this is suppose A, B, C, and suppose this is D and E. Similarly, here also we are having 2 lines, but here lines are intersecting outside the circle. Here we are having the lines like this where they are intersecting inside the circle. So suppose this is A, B, C, D, and suppose the point of intersection is M. Then one more is there, now where they are intersecting again outside the circle, but one of the line is tangent and another one is secant. So what we will be doing here? See, here there is a relation between these lines. In the first one, the length outside of one circle times of total length of secant of 1 second. The same will be with the other second. That means we can say AD times of AB will be equal to AE times of AC. Here, product of segments of one chord will be equal to product of segments of another chord. That means here we can say MD times of MC will be equal to MA times of MB. In the third one, suppose these are A, B, C and D. Then we can say that AB square will be equal to BC times of BD. Now again, we will be having three sets of circle. Here we discussed about the length. Now we will discuss about angles. So suppose this is the first circle we are having. This is the second circle. This is the third circle. So in these three circles, again we will be taking like this only, where point of intersection is outside the circle, point of intersection is inside the circle, and then point of intersection is again outside the circle, but one of them is tangent. And one more here we can take, where point of intersection will be on the circle. So let's see that. This one, where point of intersection can be on the circle. So how we can do that? Suppose this is one of the chord and one is tangent. So like this, it is tangent to the circle, whereas this is chord. Then what we will be doing? Suppose we are having this as A, B, C. Here we are having this as, here we don't need this thing. Suppose this arc we are having, this length of, this arc is subtending an angle of A at the center. Then we will represent this as A. This will be suppose B, and the angle due to intersection found is suppose theta. This angle is theta. Then, so what we can do here is, see, similarly in the second figure, suppose this is theta, this arc is subtending angle A at the center and this is subtending B at the center. Similarly here, suppose this is A, this is B and this is theta. Here suppose this is theta and this is A. Then there is a relation between all these angles in these figures. Here the relation is theta will be equal to, B is the larger angle, for B minus A over 2. Here theta will be equal to A plus B over 2. Here theta will be equal to again A plus B over 2. Here theta will be just A over 2. So these are the properties of circles. Now we will study about equations of circle. So equation of circle is very easy. So in equation of circle, we have two forms. One is standard form and another one is general form. Suppose we are having x minus h whole square plus y minus k whole square equal to r square. This is called as standard form, where h comma k is the center, whereas r is the radius. Now, from here, if this type of equation is given in the question, then we can easily find radius or center. Or if radius of center is given, then we can easily find the equation. But the next one is, this is called as standard form. Next one is general form. General form, which is like this. Suppose equation of circle is given as x square plus y square. Remember that the coefficient of x square and y square will always be same in the general form of circle. So x square plus y square plus 8x plus 4y minus 15 equal to 0. Then what we will be doing here? Suppose we need to find the center and radius here. Then we will be using completing the square method to find the equation of circle in this form, that is in standard form. So how we will be doing that? We will complete the square for both variables x and y. So if we are having x square plus 8x, we will keep together, plus y square plus 4y minus 15 equal to 0. Now if you remember, we had learnt about completing the square method in quadratic equation. So what we have to do? We have to add and subtract the square of half of coefficient of x. So half of coefficient of x will become 4, so we will be adding 16. If we are adding something, then we will subtract also, plus y square plus 4y, here we will be adding 4. If we are adding, then we will subtract also, and minus 15 equal to 0. So from here what we are getting, this will become x plus 4 whole square, this will become y plus 2 whole square, and that is equal to 16, 4, 20 and 15. We will be getting 35. So now we can compare this from the standard form. So we will be getting center equal to negative 4 comma negative 2, whereas radius will be equal to square root of 35. But there is a short formula, or you can say trick, for finding this thing, which is this equation. We have to remember this equation, which is x square plus y square plus 2gx plus 2fy plus c equal to 0. This is the general form of circle, which we will remember. See, you can see this is in the form of general form of circle. So if we remember this, then it will be easy to find the center. So you can see why we have written 2g, because if you will see, center is coming as negative half of coefficient of x. So that is the coefficient of x and coefficient of y, both negative half of coefficient of x and y. So we can say simply center will be equal to negative z comma negative f. That means negative half of coefficient of x and y, and simply radius will be equal to square root of g square plus f square minus c. Now if you will see in this question, for above question, what we were having, x square plus y square plus 8x plus 4y minus 15 equal to 0. So for this, you can see center will be simply negative 4, that is negative half of coefficient of x, negative half of coefficient of y, and then radius will be, so these are negative z and negative f, that means z and f are 4 and 2. So g square, that is 4 square, plus f square, that is 2 square, minus c, which is minus 15. So that is equal to 0. So you can see from here also we are getting 16 plus 4 plus 50, that is equal to, sorry, not equal to 0. It will not be equal to 0 here. So what we will be getting from here, that is equal to square root of 35, and that was the radius. So that is how we can find the radius and center easily from the equation of circle, if it is given in general form. We don't have even need to use completing the square method, and we can just see the equation and can say that this is the center, and with little calculation we can say that this is the radius. So that's all for this topic. We will meet again in the next video of this series. Thank you.